Hello, everybody. How you guys doing? How's school going? Yeah, it's a busy time of the semester right now. Everybody's stacked. I know I'm a little behind in my classes. It's very fun, very stressful. Speaking of stressful, we had a little stressful situation for the past hour where we had to quickly make the slide deck for you guys, so it's a little bit rushed today. We have some people presenting. We have two middle segments, and we have a guest speaker, Daniel, over there. He's in our first year, I believe, for our program. So he'll be speaking. And yeah, we'll have some quick news sections for you, and then two middle segments, break, guest speaker. And then, of course, Monahan's after, if you guys are down, if you guys aren't too exhausted. So yeah, just to get started, now we're ready. And also, just so you know, the audio in this room is broken. So if you guys don't hear anything, that's why. So sorry about that, but yeah, we can start off. I don't know who's our first person, but if you want to go on the next for the slide, I think it might be Nick who's first. Yeah, so Nick will start us off, and then we'll continue. So let's go. Thanks.
Good? Which one, bottom?
Yeah.
Okay. No, okay. Oh, no, too far. Okay, we're good? Oh, we're good? Okay. I'm not gonna waste your time. Today I'll be breaking down a new phishing kit uncovered by Push Security. A kit that targets mainly Microsoft accounts and uses a technique called browser in the browser. Yeah, right, it's crazy. Or BITB to steal credentials and potentially bypass 2FA. Okay, that's all good. The attack starts with the victim clicking a malicious link, often something that looks like a document preview, for example, previewdoc.us. Before anything suspicious can occur, the victim is met with a Cloudflare-styled bot check. This isn't for security, it's to block automated scanners and hide the real phishing page from researchers. The kit also uses conditional loading, so only the intended victims ever see the malicious content. Once past that, the user is then told that they need to sign in with Microsoft to view the PDF. When they click, the kit launches a fake login window using the browser in the browser technique. Instead of taking the user to a phishing site, it creates a perfectly crafted pop-up inside the browser that mimics a real browser window, complete with a fake URL bar showing login.microsoftonline.com, which I believe is the legit Microsoft login site. But it's just HTML and CSS designed to look real, no functionality. The victim then enters their username, password, and potentially their 2FA code into this fake window. The attacker immediately captures those credentials and session data and uses them to log into the real Microsoft account. Because this kit can capture session tokens or trick victims into providing second factor codes, it has the potential to bypass basic MFA, which is why it's being called a sneaky 2FA kit. Behind the scenes, the kit includes several evasion features, including the fact that developer tools are disabled, so it's harder for analysts to inspect the page. Domains rotate quickly to avoid block lists, and target filtering ensures only certain victims see the phishing content, which reduces exposure. The article that I read also gives broader context. Even phishing-resistant technologies like passkeys can be attacked through downgrade attacks or malicious browser extensions. So while passkeys help, they're not a silver bullet if weaker fallbacks still exist. So now we're going to get into the big picture. This isn't the first article that I read. I was actually supposed to do like a completely different one that was about a different phishing kit, but I liked this one more. Which points me to my next point. Phishing kits are getting more sophisticated and way more accessible. Attackers with low technical skills can deploy advanced phishing methods that create a very convincing illusion of trust, especially when fake windows show legitimate URLs. So in the idea of acting defensively, the key steps are, I would say, educate users to distrust any login prompt that appears as an in-browser pop-up. If it pops up, just ignore it, just hit that X, or just close the window. Use conditional access and monitor for abnormal login behavior. You should also harden your MFA by removing weak fallback methods. You should also deploy strong anti-phishing and filtering and domain protection. And in enterprise settings, I would set a tight control over browser extensions. So, in short, this kit shows that phishing is evolving faster than most users' instincts, and security needs to adapt accordingly. Thank you.
You guys like this one, buddy?
All right, who's familiar with B-Sides? Any show of hands? Anyone? Okay, we have a few. B-Sides is a community-run conference, mainly focusing on cybersecurity, but also other kinds of technology subfields, if you will. And it's entirely community-run. We have one in Toronto. It happened earlier in October, I believe. Yeah, early October. Yes, yeah, and they have one in every major city, effectively. And the community decided to put together a B-Sides Pyongyang edition. So they kind of wanted to poke a little bit of fun at North Korea, and effectively every talk that they were presenting, or every presentation that they had, they were discussing some aspect of North Korean threat vectors or threat surfaces. They discussed things like crypto laundering and how they were stealing Bitcoin or otherwise getting access to funding that they probably shouldn't have through other sponsors. Speaking of, if you go to the site, there is a list of sponsors for B-Sides Pyongyang, and it's really funny. It's effectively all the sanctioned companies. It's great. So, yeah, they live stream the entire conference on Twitch as well as YouTube, I believe, and a few other places. The records of all the talks are still available online if you just go to that URL down there. And yeah, this is just kind of, I wanted to get the word out. B-Sides is a great conference. It is entirely community run. It is like fully open source effectively. And when the time comes next year to attend B-Sides Toronto, maybe you should go out, help support the community and yeah, have a good time. So thank you.
Also, if you do end up volunteering, or if you do end up helping out with B-Sides, you volunteer, you get a free shirt, you get to go to the talks. You have to show up a bit early, but you get to just hang out with the staff and make connections that way. You get a job just from volunteering, meeting the organizers. It's a great way to get involved, So now, talk about the Cloudflare outage. So we did this, I did this in the past 30 minutes. Oh, other way, it's backwards. One more, there we go. So I watched a video on this a couple days ago. I was trying to find it in my source in I think I either watched it on YouTube or on Instagram or something. I couldn't find the original source. It was a great explanation, but decided to do this anyways with some some help, and then talk about it. So if I'm looking at my screen a good amount, it's probably because I just wrote this, an hour ago, so it's not really in my brain yet. But we'll talk about the Cloudflare stuff. So there was a outage, what was it, last week, I think? Or was it this week? It was this week, yeah. It was this week, yeah. And the CEO actually already made a statement about it on their Cloudflare site, and then a couple other blogs picked it up as well. Originally, they thought it was a DDoS because it looked like a DDoS based on all the traffic that was happening, and a lot of services went down. Basically, most of the internet went down. But it wasn't actually a DDoS. It was something else. So, like I said, they initially suspected a DDoS attack. But in turn, it was what they called a configuration attack, I believe. So it's similar to how a DDoS would affect the company or server, but it's different in how the implementation is. So they actually had something called a bot management system, which I bet you I had some notes for this here, I think. Sorry. Other side? Yes. But I had some notes here for the bot management. Yeah, so they have a bot management system, and it basically, there was a configuration file change that affected Cloudflare to have a global outage, which obviously affected millions of users, and we will go into what happened with that. So you kind of have to understand what the bot management system is for that. So the bot management system is a sophisticated security system designed to protect websites from automated threats. So it can include DDoS attacks, it can include flooding websites with traffic, it can include content scraping attacks, which harvest the data without authorization, just scraping the entire site. Yeah, very, very simple model that they run. And it runs on their Edge network, which is a case for like Edge. If you know what Edge cases are, it's like an issue where it's not a normal issue that you have like programmed for. It's just like some user comes across some edge case that's like an outlier data point. So it's like an outlier point. You haven't really programmed for it. And usually when you hit those issues, you have crashes. But this bot management system is supposed to deal with those edge cases so that the system doesn't crash and it runs normally. All right, let's go back a slide actually. So obviously it goes through the user, hits the edge request, goes to the bot management, and then it hits the actual website. So what happened was there was a feature file. I was doing some research on this earlier. The slide is a bunch of information, so I'm just going to try to talk about it quickly. But it's basically, the feature file is a dynamic file that tries to evade detection for like attackers attacking the system. And it's part of their entire proxy network for all their servers. I feel so bad looking at my screen because usually I'm just like talking to you guys face to face, but doing my best. So let's get into what happened and how it broke. Sorry, guys. Right, so they have their database. It uses a sharding architecture to shard split the databases over multiple shards, and it uses a distributed table. Each table lies in the. Does this have a pointer? Oh, nice. Yeah. So the sharding is these are all the shards, right? So it just keeps going up and it scales up all the way. It can query all the database tables, and it's usually run when the outage would have been triggered when the user hits some type of edge case. So this is what happens when this is what's supposed to happen when the user hits the edge case, but it did not happen this way. It happened a different way. So what happened during the attack was, so at 11:05 a.m. they made a change to improve security. Previously, users had implicit access to the tables, but it wasn't formally granted or tracked. The change was to make this access explicit so that the users would grant access into a more fine-grained manner. So like if you use GitHub tokens and you use the new PAT tokens, those are fine-grained tokens. You can specifically figure out what you want to access. So like organization repo admin or like GPG keys read. You select which index you want to have on your key. So that it was supposed to make it more secure. And in doing that, they added a type of generation logic, which is backwards again, which is right here. They added this. And with this is what broke and made the DDoS. So when they queried it, they basically added, it filters by table name, but it doesn't filter by database name. So it was implicitly impacting the tables, but not the entire database, which caused columns to return both the default database and each shard. So every single shard up to n, including the default database. So as you can see, the request that kept populating over and over and over again caused the DDoS or made it look like there was a DDoS attack because there was all these network traffic going to shard 1, shard 0, shard 2, shard n, and the default database consistently over and over and over again. And with this change, it basically happened within, I think it was 5 or 10 minutes, and they originally had 60 features in the file, and with the change, it added over 200. So that just basically means the system could not support it, and it panicked. It had a Rust backend, and the Rust backend panicked. And when it's a panic, it's like an error, and it's like halting the program from continuing. So if you don't check for that issue, it'll crash the server without continuing on, which is what happened with the system failure. So let's continue on again. Oh, that's backwards. Right, so I was talking before, it was 60 features, and then it changed to over 200 features because they used an incorrect query in the database. And because it was loaded with over 200 features, it hit the pre-allocated memory, caused the Rust panic, and then the global outage occurred pretty much as soon as that Rust panic happened. To stop it, it was a pretty cool timeline. They only took about 5 minutes to stop it, apparently. Obviously, it took a lot of time to propagate to the rest of the world, but internally, they stopped it within 5-10 minutes.
The interesting thing to me about that is that their system automatically updates every 5 minutes.
Exactly,
So
yeah.
It could get fixed like that.
Yes.
How
long does it take to propagate to the rest of the world? Exactly. Yeah, exactly. So the outage begins, the bot management system crashes. Within 15 minutes after the query was changed, you can start to see traffic start to skyrocket in the network, and they started freaking out. All the services, Twitter, X, YouTube, stuff like that would just die out. And then within an hour and a half, they figured out what happened. And then within another hour after that, they were able to roll back the propagation, or roll back the database change, and it started propagating with the rest of the services that they offered. And then 300 minutes, which is I think 5 minutes after they found out. So that's pretty, 300 minutes, that's 5 hours. Sorry guys, 5 hours, not 5 minutes. It's a bit long of a day for me. So yeah, like Wyatt was saying, they update every 5 minutes, so it was interesting to see how it could have been fixed, but wasn't, and it took them a lot longer to fix that. If they just figured out what kind of query they wrote better, it probably wouldn't have happened this way. But yeah, some takeaways, we can go over that as well. So this is more of a programming takeaways, but defensive programming, this is basically just like using the given, not variables, but given
Rust apparently doesn't handle error handling that well? I don't understand.
It does quite well. It does quite well. It's just when it does crash, it's bad.
Right.
It crashes really bad. Like when it panics, it's not a good thing. Like just for side note, I was making a program in Rust, or a web app in Rust with my friends earlier this year, and we were having so many Rust issues on the back end on production, and I couldn't figure out what the issue was, so I installed this service called Sentry. I don't know if you guys have heard of it. Basically watches the code, front end, back end, and mobile, if you have mobile, and it'll watch for any crashes or any error routes that, like endpoints that are failed to be reached, or something that's taking multiple seconds to fetch. And when it kept panicking, I would get email alerts or text alerts that the Rust backend panicked and crashed on production. So if you are using any type of language and you have a production server, I would recommend putting Sentry in there. It would help you to watch for crashes and issues and stuff like that. But for defensive programming, like this one here at the top, if I can, like that, this one. Basically, you need to match error handling as well as you can. Rust is very type strict, like they're very, very strict with types. So if you have, like, you're passing a file or passing an object or something, you're not using the right file or the right type, it'll scream at you. It won't even let you run the program. Even if you have the type safety and it finds the panic and the panic is not configured properly, you'll just crash. So try to use proper programming techniques when you're dealing with production databases like this. The other one is make sure you're validating all inputs when you're using database queries, right? So this is what happened with Cloudflare, where they didn't validate the proper where clause. It was pulling from all of the databases instead of just, or all the shards and all the databases instead of the specific shard that it was meant to be pulling from. So make sure you're writing proper queries. You can even use prepared statements if you want. Configuration rollouts, this is good if you're a service like Cloudflare where you have an update and you want to push it to a bunch of users. Don't push it all at once. Try to push it, little by little, just so you can see if there's an issue with some of the services that you're pushing with. At least then your entire service won't go down and it'll just be a few, which is not ideal, but it's better than tens of millions of users. And independent monitoring, you can use status pages to track your outages internally, externally, and it just helps you to diagnose the issues a lot faster. And I think I have the last slide. Just the basic conclusion is basically the same thing that I said all over again, but if you are not configuring your infrastructure properly, you will have a similar security issue as if it was a normal like ransomware attack or a malware attack or a vulnerability exploitation or something like that. These configuration attacks are becoming more and more popular. I say attack, but it wasn't even an attack. Cloudflare did it to themselves. But that's not the first time. Cloudflare also did this to themselves like a couple months ago with the 72 terabyte or 17 terabyte per second DDoS.
They did that to themselves.
Yeah, they did that to themselves. Yeah, so they used a React hook called useEffect. They used it incorrectly, and it basically called like 10 million times. And they sent themselves like 17 terabytes worth per second. Yeah, for like a couple seconds. And they had to come out later. They're like, oh, my bad, whoops. Because they came out saying, oh, we got DDoS attack, biggest attack in history. And then like 2 days later, like, oh yeah, that was us. My bad. And then a week before that.
They got DDoS again.
Yeah.
But it was like half the size.
Exactly. And then in between those two DDoS attacks, they implemented a new AI system within Cloudflare. Actually, they released something called, I think it's called Vibe DK, so like Vibes SDK, but like Vibes DK, Anyway, so they called it that, and in between that implementation and the two DDoS attacks, the useEffect thing came out. So I'm under the impression that some person started using the Vibes thing internally, and AI just hallucinated and made this useEffect call. And because yeah, you can make useEffect calls like break in local code and production code, but to have Cloudflare do this, it's pretty sus, to be honest. But I think that's it for me. So sorry it was a little bit out of it. But yeah, we got, thanks. Appreciate it. So now we have Jamie presenting some stuff. I have no idea what he's going to talk about, but it's another middle segment, so probably another 10, 15 minutes. Then we'll have a break. And yeah, so all right, that's it. There you go. It's a bit confusing, that one. It's this way. I think this way's up. I think. You can try it out.
Let's see.
The light.
Okay.
I think it. Yeah. So maybe it's flipped.
Front is.
Yeah. So
Okay.
I think the light is this way.
Oh jeez, I'm not gonna use
And
the
then-
light. That's too much technology.
Too much work.
For me.
Too much work.
Jesus. Yeah. Okay. Hi everybody. I'm Jamie. Socrates on the channel. I was asked to do a new segment tonight. As you heard, we had a bit of a organizational hiccup, we'll say. I also want to say that my favorite part of B-Sides Pyongyang was they introduced the first Windows 98 computer in North Korea, and they were ecstatic. I'm just kidding. I wasn't there. Wasn't invited, but maybe one day we'll go. Okay, so we're going to talk today about UNC 1549, and you're probably like, Jamie, why are we talking about your uncle? We're not talking about my uncle. And UNC is Mandiant's way of grouping clusters of cybersecurity artifacts or behaviors in a group. We like to group things, and then eventually, if they grow up and mature, they become an APT, which advanced persistent threat, those are bad. We don't want those.
Really quickly, do you want to just say what Mandiant is?
Yeah, so Mandiant Consulting is one of, I would say probably the leading cybersecurity consulting firm in the world. They do a lot. And this is one of many things that they cover. They just posted this article a few days ago. So with that being said, this is not an official Mandiant presentation. I read the article, and I'm going to give you kind of the highlights and my interpretation of what's in the article. So keep that in mind. All right, let's see how you do, Clicker. Okay, so to start, let's go over a little diagram on the top because that's super important and it's gonna make everything make sense. So this is actually what Mandiant uses internally to kind of stage an attack, and this is public information. And what I like about this versus like MITRE or anything else is that there's a loop, which means there's a cycle, and that's because attacks are cyclical. They don't go in order and then they do like one thing and then like, oh, I'm done. They get in there and they keep iterating and repeating TTPs. Tactics, techniques, and procedures. And there's a whole gigantic list of them. We're not going to get into that today. That's a whole thing on its own. But it's just important to note that once we get to the foothold and they're in the system, it now becomes a cyclical thing, and you know it's done when they complete the objective, or hopefully you intervene and kick them out. So, initial compromise, what does that mean? Well, that's just how do you actually get into a system, right? Because we're in cybersecurity. We know there's all these products and all these acronyms and all these things that we do to keep things secure. How does this happen? Well, quite frankly, the weakest point is always a user. So UNC 1549 loves social engineering and spear phishing. Social engineering is just a really fancy way of saying they're incredibly charming and they know how to call people and talk to people to get information. And that doesn't necessarily mean like they go up to the system engineer and go, hey, I need the root password for, your edge layer proxy network. No, it might be like, man, those managers, they get paid way too much money. And you might be a manager and say, I don't make that much. Oh, well, I think you make tons. Like, oh, I'm only making X amount of dollars a year. Well, now you know how much they make. You can start profiling them. You can start thinking about, and they do things like that. They call in and they start building this kind of profile, kind of like traditional profiling. And with that, they do a thing called a spear phish. And Nick did an excellent talk on phishing, which I would describe as kind of like blasting out phishing. It's like, let's send out a million things and kind of see what hits, right? But a spear phish is specific, right? So it's spear phishing is we throw the spear at like the biggest fish in the pond. So the idea with a corporate structure is we're trying to target someone very specific. And you usually figure that out with social engineering or things like LinkedIn. You can go on LinkedIn and find out, hey, who's the site reliability engineer at Cloudflare? Because that guy's getting a huge raise for rolling back all that stuff. Maybe I should target him. So that's where this all starts. After that, there's kind of two really cool things that one really cool thing they do and another thing they do. Compromise third-party credentials very simply means that they acquire credentials to things like VPNs or proxies, and they get access. And that could be as simple as going on the dark web and buying them. You can buy a gigantic spreadsheet of credentials and log into things. Or there might be some inside work. In the case of UNC 1549, they're believed to be a nation-state actor. Right now, they're targeting Israeli infrastructure. So throw some geopolitics in there. You can probably ascertain where they're getting things from, right? Not to get super political, but just it makes sense for the cybersecurity aspect. Virtualization breakout. This stuff is really cool. What essentially that means is everything you've been told about virtualization is a lie. So we all know you spin up a VM or a container, it's supposed to be this beautiful little self-contained terrarium of all the things you're doing. And that's like mostly true. But really smart people who have an intricate understanding, a very specialized understanding of virtualization can actually break out of it. Because at the end of the day, it's just special system calls being made to the processor, and if you know how to manipulate that at the assembly level, you can do whatever you want. And if you have that knowledge, the knowledge is power. So very advanced, very capable group of people. So that's how they get in. They figure out who they're going to attack, they target them with phishing or something, and then they're using these breakout systems to kind of get in. Okay, so now they're in, right? They've gotten into the system somehow. They've got a terminal, they've got a website, whatever. Establishing a foothold. This would be known as persistence. So this is just how do I now stay in the system, because obviously they're trying to keep me out and I'm going to be doing things that might cause suspicion. I should probably not get myself kicked out. So there's a lot to this. There's probably a dozen pieces of malware that are involved in this attack. All I really want to cover is that the malware samples were not unique. And what does that mean? For each malware, the malware itself, right, which is just software that does bad things. It's like software is good and malware is bad. The malware was not unique, right? So they were kind of all the same. What was really interesting is they run the malware, right? They get into a system, they run this malware, and then we have something called a post-exploitation. So we've run the piece of software, and there's a payload, and that's the actual thing that we want to execute. Those were unique. Oh, wow. Yeah, so that's incredibly advanced, And we won't get into the nitty gritty of that, but essentially what that means is every time they build this piece of malware, they run the piece of malware, it essentially can change itself enough so that to the system, the hash is different and it looks different. So if you're a detection engineer and you're like, I've got the hash of, I think one of them was mini bike. Oh, I've got the hash for the mini bike exploit. It's like, no, you don't, because they're changing it every time. So your traditional detection does not work, which is a big issue, big issue. Yeah, so that was really cool about the malware. If you do want to read more into it, it's in the article in the beginning. It's a deep read, but if you're into that kind of stuff, I would definitely check that out. Okay, so talk a little more specifically about what's cool about this malware is it uses something called DLL, search order hijacking. Let's talk about this. A DLL, dynamic linked library, if I have that correct, is essentially a way that you can extend a Windows application. So you have like an exe, right, or like a regular executable file, but I want to add stuff to it, or better yet, I have a piece of code that I want multiple executables to have, and I just want it to kind of grab it from one place. I don't want to have 1,000 copies of the same code. I'm going to write one DLL and just reuse it in different executables, right? And that sounds like all the programmers are like, yes, I write it once and I never have to deal with it ever again. Cybersecurity people, we hate this. This is one of the worst features in Windows. And traditionally how this was done was actually just modifying DLLs directly. So literally you find the file, you open it up with your root access, you change it to do all the bad stuff, and you run it. Windows has gotten better. They've gotten smart. They now actually track the hashes of DLLs, so when a new build of Windows comes out, there's a list of files that they know the hash of. So they know the exact, right, you change a space in that file, new hash, right? So attackers go, okay, well I can't just go in there and change it, but what if I just wrote my own? And now you might be thinking, well hold on Jamie, you just said if I change the contents of a DLL, it's gonna, make a big issue in the system. Well, again, programmers, they don't always think of everything. They don't always think of everything. When writing these applications, there's this really good, bad, questionable thing called relative pathing. And all that's saying is, hey, when you run explorer.exe, look for, this DLL file, and normally it's in this location. And that's essentially what the code is saying. Well, as an attacker, and I'm doing my research, I see that file and I go, hey, well, what if I put my file there? It's in the right spot, has the same name, and this piece of code is not checking for the security of that DLL file. Yeah, you just now can run the code that you want to run. And that's one of the tactics that they use. So they took a DLL that runs with Explorer, which is your file explorer in Windows. So yeah, every time you would run Explorer, it runs bad code. And when you do forensics on that, it just looks like Explorer is running. So how do you detect that? Well, you have to build detections for that. You actually have to know the technique that's being employed, and that's why we study these. So DLL search order takes that a little bit further in that even if you now build the detection for the name of the file, you can actually pull a search order table, which is essentially just like a lookup table of this is the location that this file is always going to be in relative memory, and it's even less of a check. So you can actually redirect it in memory to a completely separate file that could be on the internet, which is horrible. So incredibly advanced attack, right? They're able to get in, break out a virtualization, run this malware that is virtually undetectable unless you have companies like Mandiant doing research on them. Incredibly advanced. I'm looking up here and I fully recognize this monitor in front of me. Okay, so you run the malware, you get your payload installed. What do you do now? Well, according to Mandiant and their documentation, we want to escalate privileges. So I've gotten in, but I want admin, right? I want root. I want domain admin. I want more from the system. They're using some crazy custom tools. There's a ton here, and I have, I believe, some notes on this. I don't want to get super in-depth as to what it is. Okay, yeah, I didn't want to talk about this. So they're using a tool called dcsyncer.slick. So domain controller syncer.slick. And what this is doing is mimicking the tool that syncs domain controllers in Active Directory. Simpler terms, in a Windows environment, you have multiple servers that kind of govern what's going on with other Windows servers, like who are the users, who gets access to what, and they sync, right? Like they connect to each other and they share information. And there's a piece of software that does that, and attackers can mimic that software and essentially create like a proxy or a redirect. And say whatever they want. They can say there's a new user, there's this, there's all kinds of stuff going on. Again, incredibly in-depth. The key thing I want you to take note of, though, is it's replicating a legitimate Windows feature. So there is no detection, because they're using a Windows tool. It's signed by Microsoft. It has a function, but they're just kind of repurposing it for bad. And if you guys heard my talk a while ago, this is right in the vein of like the LOLBAS, right? Living off the land, binaries, and scripts. So using things that are already in the operating system. I don't have to drop a file. It's already there. And it's signed. It's not going to blow up a detection unless you use advanced EDR rules. Really, really cool stuff. It's bad, but it's cool. I'm going to keep looking at this, guys. So just take it in for what it is. Okay, perfect. Conrad added in. So living off the land, all that means is we're using the tools built into an operating system. So Windows, AD Sync, it's built into there. So internal reconnaissance and lateral movement are technically two different phases, but they usually go together. What does this actually mean? This means that they get access to a domain controller. They run net user, net group, net SA. There's all kinds of built-in Windows things to essentially do like Windows administration, right? I want to see, hey, where are the other servers? What are the other users? What are the other services that I can see and access now? And that's why this is a cycle, right? Because you might pivot to this next one, get in there, do your stuff. This sucks. Come back and keep cycling over. And that's actually what I really love about this diagram, is it's way more accurate from what at least from what I've seen. Perfect. Maintain presence. So we talked earlier about established foothold. Now you're like, what are you talking about? Maintain presence. Establishing foothold is specifically keeping the malware and keeping the initial connection there. Maintaining presence, I always like to describe this as them being a little bit smarter and sneakier about how they're achieving their objective, right? So the foothold is all about getting the malware and getting the C2 connection. C2 is command and control, and that's just a fancy way of saying attacker has a server that deploys a client, or sometimes doesn't deploy a client, and it controls that computer, and that's where they execute all this bad stuff. So after they've done that, they now want to create a better persistence mechanism, because that's really loud for the most part, right? If I'm scanning the network, if I have good EDR rules, I can probably detect C2 traffic. What I can't detect, and this was really interesting about this one, is they were using Microsoft Azure Web Apps. And some developers here might know what those are, and some sysadmins might know what those are. But essentially a web application is API access, right? So web API access to your 365 tenant. And they're awesome. I'm using one right now for email where you can pull a user in, have it read all the emails for that user, and then have that actually create security policies based off the ticket. Like, there's lots of cool stuff you can do with them. But whenever there's cool stuff you can do, there's also bad stuff you can do. Like just read the entire 365 tenant. And this is very common because DCs in the modern day and age are hybrid. So they're local, but they're also connected to 365. So if you're not auditing that or you don't know to look for that, it just looks like regular web app traffic from your 365. And that sucks because now you have to go and audit all your web applications, which might be a ton. So that was really cool about this. The C2 traffic, as you see there, is the SSH reverse tunnel. So they create an SSH connection in, but then they proxy that back out on a different port that's hopefully not being scanned. Usually, well, it's already encrypted with SSH, but they might encrypt it again. They might encapsulate it again, send it out. There's cool C2s that work on DNS now, where you can actually put commands in DNS packets. So it looks like someone's looking up a domain name, but in reality, they're executing code on their web server. I had a case that was really interesting. So, I don't know if I should have complete mission, I hope. Yeah, I do have complete mission, good. Okay, so what are they doing? Well, we talked earlier, we're pretty certain it's an Iranian government actor targeting Israeli infrastructure. So they're mostly concerned with data exfiltration. Who knows, it's probably military related, it's probably infrastructure related. It's not good, you don't want people having that information. And yeah, it gets exfiltrated on those C2 servers, those 365 web applications. And if you're not looking for that, you're not going to find it. So this is the importance of the blue team, defenders, where the research is important because if we're not looking for it, it literally just might not get found. So that's what's really cool and like really noble about security researchers is they're the ones digging into, hey, what does this API call in Windows do? And what's the cascading effect of that? And I'm boring the shit out of all of you right now, but super important. So this was a great article. If you want to read into it, it's great, super technical. They have excellent write-ups. But what I just think is really cool that they combine the social engineering with virtualization breakout, a really cool DLL exploit, and then it's just using built-in Windows tools, which I've always been fascinated in forensics, is just using the built-in stuff. And yeah, so that's kind of my breakdown on UNC 1549, and yeah.
You want to put the article in stream questions as well?
Sure. Yeah. I'll post it.
So Jamie will put the article in stream of questions if you guys want to read it as well. I'll put the Cloudflare stuff as well there. If Nick or Conrad wants to put theirs, put it in the stream questions. So we're going to go on break. We probably will just have a quick 10-minute break. And for the CCR code, I'll post the form in stream questions. This is just for anybody who doesn't know. It's just it's club hours, and I think you have to hit. I was talking to somebody about this today. I think you have to hit 10 club hours to be a member, but to be like I don't even know. I think to show on your record you need to have 40. I think it is. Does anybody else remember? I think it was 20. 12? Okay, a bunch of different numbers. Whatever. It's not that much, but if you come to a couple a couple sessions a year for a couple years, you'll hit the member limit. I mean, like. The only thing that is related to is like technically you can still be a member without being a member. It's just for like shared-in stuff. So it's like you can prove to your employers that you have like extracurricular stuff if you fill out the CCR form. Is basically all it is. So yeah, give us 10 minutes. We'll be back. Okay, guys, we're just gonna get started. And some ransomware stuff. This should be pretty fun. Some in the field experience work. So hopefully you guys enjoy.
On the ground in the trenches.
Yes, exactly. So it should be a good presentation.
Thanks, everyone. So the story I'm here to tell is from my early days working for an MSP. That'll be a managed service provider, basically outsourced IT. It was essentially my job to run around and fixing everything that went wrong at about 24 different offices. So one of our clients, one day, the president noticed their file server, all the files, their names were starting to change. So he did the right thing. He opened up a ticket, and then he called my boss, and my boss picked up the ticket and decided I should handle it. I'm assuming it's because they decided it was a level 2 tech, but I don't know that because they never told me when they upgraded me to that. I am not naming names for obvious reasons. But anyway, I picked up the ticket, hopped on the file server, and I saw a wall of profanity. It was like someone took a random word picker and hooked it up to 4chan. And every file was just like all the way across the screen in their name. So yeah, I updated my boss and the president, let them know, hey, this company's been shut down. Disconnected users from the server, first step. Second step, looked at the files, checked to see who was editing them. Found the account of the user. It was a user that I knew was working that day. And chances would have it, I had their phone number. So after locking all their accounts, that would be Windows, email, and VPN. They were working remotely, so they were actually on the VPN, which is actually turned out to be a good thing. Called them up, told them what happened, and told them to just shut down the computer and sit down for a while. So at that point, it appeared the attack had finished. I didn't know that for sure at this point, but that's what it looked like. I went back to the server, shut down the server, and part of my job at this company is maintaining the backups. So thankfully, I knew we had good backups of the server. So I just ripped out the partition that had all their files on it and rolled it back to the previous day. At this point, my hands mostly came off of this, and it escalated up to people above me. But I did hear about what was found. So what had happened was a malicious email came in. It managed to get around the spam filter. The user saw it, clicked on it. The malicious payload ran. The antivirus decided to see what's going on and wrote a log. And the payload continued to run. Again, not naming names. And the payload then used a escalation technique to start operating with local admin privileges on the machine and saw that there was a file server and decided to start encrypting everything. But thankfully, not everything went wrong. We did have layers to our defense. The user was connecting to the office through a VPN, so all they could do was access the file server and not even completely just browse the files and access the files. They couldn't try to connect or do anything else. So the server itself was completely clean. We scanned it, we scanned all the other computers at the company, but thankfully we were following the I think the word is principle of lowest privilege. And this user didn't have very many of those. And we were able to get that laptop off to forensics. They did what they do, and I'm sure a lot of you are more familiar with that than I am. And they found that there was no data exfiltration. And then I spent the rest of the day watching a loading bar as our backup software started pulling the backup off of platter drives and onto the server. And by the next day, we were able to get them back up and running, and thankfully nothing much was lost except maybe a day of work. Any questions?
So having gone through this and now doing some time in the course, what's one thing, if you were to go back as your own consultant, would you say to that client, hey, we need to do this in retrospect of that attack?
I wouldn't actually be talking to my client, but what I actually found out, that antivirus that we were using, that we had deployed everywhere, and was also replaced within a few months of this attack, was known to behave like this. I looked up tests of various antiviruses, and compared to every other antivirus, it was a mall cop. It would see things and write a log. It would see, oh hey, there's a virus over there. Make sure the user knows about it. My job's done.
It's a logging system, basically.
Yeah, it was a mall cop. It would see things and tell you about them, but wouldn't prevent any damage. And also, another step we took after the fact, we implemented MDR, Managed Detection Response. The difference between MDR and antivirus is antivirus has a list of definitions, and it will identify viruses based off those definitions. MDR monitors behavior. So an unknown virus can come in and start doing something malicious. MDR is supposed to catch stuff like that. It's supposed to see when a computer, oh hey, the computer is suddenly accessing every file on the file server.
In 1 second or something,
Yeah. And then there's MDR and there's MDM. MDM is Managed Detection Monitoring, so that's a mall cop. And there's MDR, which is Managed Detection Response, and MDR can act. So if it detects the malicious activity, it can act and isolate that computer. And what I would do if I went back would be talk to my boss and say, hey, why are we using this software? Because yes, the user shouldn't have clicked on the email, but clicking on, this wasn't a sophisticated attack. This was a known virus, a known exploit, and our security suite just let it happen.
I had a question, but I forgot.
Yeah.
It was, no, I lost it. It was a basic question too. Did you guys have like a phishing training for your employees, or they just clicked it for they didn't know? Or?
For the employees, for my employer had it.
Yeah.
I had to go through it. Not every client would do it. That is something each company would on their own decide. I don't know if this one actually had it. That wasn't like.
Even if they had training, I mean, people click the
Yeah.
sheets all the time. Sharon has it where if you see the phishing email and you click it and you fail it, they'll literally send you an email saying you failed the phishing attempt, and like your email gets logged and sent to IT.
Yeah.
And, like they'll start sending you like training emails for like a certain amount of period until like they realize like maybe you're not paying attention.
Yeah, we actually had another client, much bigger company, who did those tests regularly, and one of the newbie techs on our side blocked the phishing tests
Nice.
because they were reported as spam correctly. I was like, oh, better block that. And then my boss got an angry phone call.
Cool. Any more questions? You guys good?
Was it just a payload that was launched as soon as the email was opened, or was it a link within the email that actually had it correct?
I actually don't know the details there. I didn't get any report from forensics. I'm just told there was a malicious email and the payload was delivered through it. The user did have to click on something, but unfortunately I don't know the nitty-gritty.
Awesome. Well, thanks, Daniel. Appreciate it. So we're finished a little bit early. I just had the bright idea of asking if anybody wants to talk about something quickly. They had a cool project they're working on, you know, you can talk about it, or some idea, or some article or something, if anybody has any interest to speak on something. If not, then we're... If you want, you're welcome to continue. If not, we'll head over to Monahan's, which we do not have a reservation for, which I will make a call for. But yeah, do you want to go again, or? Yeah, sure. We'll do another 10 minutes then. Just before we start, does anybody actually want to go to Monahan's, so I can get like a quick head count? I mean, like usually we do like 10 people or so. I mean, obviously it doesn't have to be 10 people. I just went for the reservation. Anybody has any interests? Okay, I'll call for like 10 or 12 people. Okay, sounds good. Yeah, I'll go make that call while you continue.
All right, let me tell you about how another client got robbed. So this was actually not the same employer, but similar business model, similar business. Another MSP. I was another tech at a bit of a higher position. I didn't actually have a hand in anything that happened here. I was just briefed on what happened, and I love pulling this story out anytime someone complains about MFA, because this client had been dragging their heels on turning MFA on for Office 365. And let me tell you, any Office 365 implementation, including here at Sheridan, you have to expect someone to try to brute force it. It's easy to do. I don't know exactly how to do it, but anytime I hacked one of my clients, there were logs always from somewhere across some ocean of dozens of failed attempts. So this client had been ignoring us, telling them this, and not wanting to do all the legwork of implementing MFA and ignoring their users. A user's email account got breached. The attackers logged onto the email account. They saw that this person was in charge of collecting payments from their clients. So, with the legitimate email, sent an email to a client saying, hey, we're updating our payment collection. Instead of paying us the old way, pay us this way. Then then a real invoice came out for real work that was done. And the payment went right to the attackers. And I believe my client did pursue legal action to try and get paid again, but I don't think they were going to convince these people to pay for the same work twice. I also know the CIO who had been ignoring us was no longer working there within a week. And a third little tidbit, the client manager who does all the communication and all the major recommendations used this story, and suddenly all of our clients were implementing MFA. Sorry?
Themselves and you.
Yeah. So my client got robbed because they didn't listen to us. CIO got fired, and suddenly we had a real easy way to convince everyone else to listen to us. Yeah. Yeah. So to say about MFA. This passes there.
Well, that's the end of the session. Thanks everybody for coming. I think our next session is December 4th, I think. Well, so I've asked the content team and stuff, and organization team, to see what we're doing. I asked them, I haven't heard back yet, but I'm assuming it's December 4th for now. The weekly workshops that we have, we're trying to keep them after Cyberside. So, just so you guys know. Yeah, no worries.